Alright, so I'm going to be showing you guys the problem from Trench 5.5, problem number 7. This problem states this equation right here. And it tells us to find the particular solution. So, I mean, we've seen this kind of equation before here equal to 0, and we know easiest that we're able to solve it for 0 using different variables in a previously defined term where m squared plus 4 equals 0. And through this we can find, and make sure that doesn't look like a y, through that we can find that m is going to be equal to positive or negative 2i. And through the Euler's formula that we were able to use earlier as well, we can find that our complementary function, you put y sub c there. I'm going to star that because we're going to need to know that for something later. That's going to equal the first constant times cosine of 2x plus the second constant times sine of 2x. Now, we need to know this because if you look at the equation on the right, when it doesn't equal 0, it actually equals this whole function. You can see that there's both a cosine 2x and a sine 2x already in there. Now through that, we need to add an extra x variable into this, which is what the textbook and videos were saying earlier. If our solutions didn't come out to be cosine 2x and sine 2x, if they came out to be cosine 3x, we would leave the particular solution out to be a cosine 2x plus b sine 2x. But because that's already part of our solution here, we have to multiply in an x variable. So I'm going to cross that off. Our actual particular solution is going to be ax cosine x, 2x, plus bx sine 2x. Now we have to fit these into this equation here. So you don't have to do this normally, but this is helping me, I find, when I'm showing you guys. You highlight the solutions that you're going to be putting in here. That way it'll make it easier to plug them in later. Now y prime, even though this isn't going to be in this solution here, we're still going to use it to find y double prime. Now, I also find that it's easier if I try to highlight the coefficients of each sine or cosine function, or underline them like this, not like that. That way you can simplify this down and make it easier to differentiate. So if you do b minus 2a quantity multiplied by sine 2x plus a plus 2bx quantity multiplied by cosine 2x, that'll be easier to differentiate, which we're going to do now. So to simplify it down, yp double prime is going to be equal to 4b minus 4ax cosine of 2x if we add those two, the 2b here and the 2b over here together. And then same thing with the sine and their coefficients. We're going to have negative 4a minus 4bx is going to times the sine 2x. So we're going to be using that also in this equation that they have given us. So we're going to plug all of these all into each other. This whole long thing is what it comes out to be. We can obviously combine all the terms here though. So what I've done is I've again highlighted, in the test you could probably do something more like this because you're not going to have highlighters with you. But for the sake of showing you guys, I'm finding that this is easiest for me. We find the 2x coefficients and we add them all together. Obviously that's going to equal that on the left, right. So 4b minus 4ax plus 4ax. Those two terms cancel out, times cosine 2x plus negative 4a minus 4bx plus 4bx times sine 2x. Those terms will also cancel out, equals our negative 12 cosine 2x minus our 4 sine 2x. So we can show, because we know that there's a cosine here and it's added, it's not multiplied. If it was multiplied, this would be completely different. But because these two terms are added together and these two terms are technically added together, even though that's just part of the coefficient, we know that we can set these equal to each other. So this comes out to be 4b is going to equal negative 12. And then negative 4a equals negative 4. A is going to equal 1, and b is going to equal negative 3. Now, from way up here, you have to plug in those coefficients into here. Particular solution is going to equal 1 times x cosine 2x minus 3x sine 2x. And it's just asking for the particular solution, so this is going to be our answer.